Hello, welcome back to mechanics. We're looking at motion in 1D. So let's just continue and look at part 2, which is equations of motion, right? So let's just start with something that's very important, but before we get to equations of motion. So we last ended on acceleration, right? We described the acceleration as a rate of change of a rate of change of velocity, right? So this is ax, which is a change in vx over change in time, right? So we have different types of acceleration. We have positive acceleration. The positive acceleration means that velocity is increasing in the positive direction, right? Because we know we choose a direction. We have a direction, so velocity. If velocity is increasing in the positive direction, then we know that our velocity is positive. But how do you know when your velocity is increasing in the positive direction? So it works out like this. So, for example, you have someone running um, like this. This is a person, right? Let's just say this is our person running, right? Can indicate this like that the person is running to the right. We know that right is our positive direction. Let's say initially when they passed position 1, the person was running at 2 meters per second, and then when they passed position 2 here, running at what, 5 meters per second, right? So they increased their speed, right? So the person increased the speed, right? So it moved from 2 to 5 meters per second. So we have an increase, we have a change in speed, right? So velocity is increasing in this direction, which is in the right direction. So it propels the motion forward. That's what we call a positive what? Positive acceleration, right? So let's say, for example, let's just look at a negative acceleration, which is the opposite of that. So negative, so you have velocity decreasing or dropping in the positive direction, right? So let's just look in one direction, the positive direction. So this one, number one, Roman figure one, this is right. When something is speeding up, its acceleration is increasing, right? Its acceleration is increasing, so it has a positive acceleration. So when velocity is decreasing, so let's just look at negative acceleration. How does it look? We can plot that. We can show that here. Let's say we have this, right? And then we have the same person running. Okay, we have our sprinter here, right? As you can tell, so I tried to show this was running very fast, right? Because it's speeding up. And then now, let's say the person was moving what? When the person moved here, was moving at 5 meters per second. This is x1, right? And when they got to x2, now the distance is 2 meters per second. What happened? The velocity is now dropping in this direction, in the forward direction, right? Velocity is what? It's dropping. So your change in Vx is negative, right? It's negative. What does that mean? By our if this is negative, and we know that ax is equal to change in v over change in time. Time is a scalar, so it doesn't have a sign. It's always positive. So that will be what? that will be a negative acceleration because this is negative, right? So what's happening there? The object, the person, the vehicle, the rock, the pendulum, the box, anything that is in motion is slowing down. This is what we mean when we say you have a negative acceleration, right? So it's a change in velocity, but if that change is now reducing and reducing, then you have what you obviously have a velocity that's decreasing in the positive direction, and then you have acceleration, right? So let's just show that because now we're showing with symbols, right? If here velocity was in the right direction now, acceleration, I mean, was in the right direction, right? When, because it's speeding up. When it's slowing down and the velocity is negative, it's now in the opposite direction, trying to slow the object down, right? So that's what negative acceleration means. This is what happens when you apply your brakes. This is what happens when you do what your when you're in a bicycle and then you press those handles to slow down. Is it that's what happens when you try to slow yourself down? You are reducing the velocity. This is what friction does. This is something that opposes your motion does. It pulls you back, slowing you down, right? So let's look at constant velocity, right? Because we at constant acceleration, I mean, we looked at positive and negative, but what does constant mean, right? So constant velocity is when you have no change in velocity. Constant acceleration, I mean, no change in velocity, right? So let's just draw. I like to draw to actually show you what's happening, right, with your what's happening, but visually, because I find that things are much better to understand when you visualize them. So let's do this, right? This is x1, this is x2. Let's also have x3 here, right? You have 2 meters per second. You still have 2 meters per second. You already have 2 meters per second, right? So this can happen with a car which is on a heavy traffic, right? Let's say it's a peak hour and there's too much traffic, so you're maintaining a constant speed, right? So your velocity is constant, which means that you have what, no acceleration, right? Right, so you have zero acceleration. So yeah, constant velocity, no change in velocity, you have zero acceleration. So let me just indicate that, because I say that this is constant because this part is acceleration. What is constant is the velocity that side. So you have zero acceleration, and this is what your velocity is constant now, right? You have negative, positive, zero, right? And then so let's just see how that looks like. So this is what you're moving to the right, right? You have what? No acceleration, no acceleration. Why? If it's like this, right? We have change in velocity over change in time. These are the same. 2 minus 2 over change in time, just have 0 over change in time. What is that? 0, right? So your acceleration is 0 if you have constant velocity. Every time when you hear that there's constant velocity, you should know that there is 0 acceleration, right? So how does this constant acceleration look like, right? So let's just look at constant acceleration. So constant acceleration is when you're changing your velocity at the same rate, right? I don't know if I'll be able to represent that on a graph, but okay, velocity changing at the same rate. Because when you speed up, the velocity is changing at a different rate. You keep increasing the acceleration, and then when you slow down, changes a different rate, just in the opposite direction. When there's no acceleration, a constant velocity. But what happens when velocity now is changing at a different rate, at the same rate, I mean, at the same rate. So what does this mean? Let's just try to show it here. I'll just show it x1, x2, x3, x4. So this space, let's say these ones are uniformly spaced, right? Let's say x1, let's say the distance here is the same. I know it doesn't look like that, but let's just say it's the same, right? So if the distance here is the same, right? So and also the time is the same, right? So the way you change your velocity, what it's changing at the same rate. It's changing at the same rate. Velocity here, another velocity there, different kind of velocity, different kind of velocity. It's changing at the same rate. So that will be your v. Say this is, if this is your v1, we know that is your v x2. We know this is your v x3. So by each displacement you change by 1 1 1, and then you, let's say you have 4 vx, right? So this is changing at the same rate. You don't have speeding up or slow, you don't have speeding up rapidly or slowing down rapidly. It's just changing at the same rate. This could be a negative what change, could be a positive change, but it is constant, right? It could be, this change could be in this direction, which is positive, or in this direction, which is negative, as long as the acceleration is constant, right? It's a constant acceleration. What is accelerating? Rate of change in velocity, right? So let's just show that rate of so let's say this is 1, right? So this will be our 2, this will be our 3, right? So that it matches. So let's say, for example, we want to find acceleration for this. We know it's Vx over Vt, which is equal to what? 2 V change in Vx over 2 change in Vt. Same thing, so it remains constant, which will be equal to what? 3 change in Vx over 3 change in Vt, right? Remains the same, so that's what it means. So let's just go back to so let me just give you a summary of what we looked at. We looked at velocity and acceleration, right? What does it mean when you have positive acceleration, negative acceleration, zero acceleration, constant acceleration, right? So when we look at equations of motions, right? So let's just look at our equations. Equations of motion actually utilize what they are also called constant acceleration equations. So we use a constant acceleration, which means if your acceleration is positive or negative, which is increasing, it does not apply for your equations of motions do not apply. They only apply if you have what? Only constant acceleration. Okay, only applicable for constant acceleration. Alright, so that's what we have. So how do we actually get our equations of motion? Let's just get started. So we know ax is equal to change in vx over change in time. We can just say this is our v final minus v initial, which could be v2 minus v1, doesn't matter. So you have this, right? So you can manipulate those that equation. So this is our main equation. What? Because this is our constant acceleration, right? So we have the same rate. So this is our main equation, but we can manipulate that equation to get our equations of motion. So I'm hoping that when you watch this video, you already learned in class what equations of motion are. And here I'm just giving you a background on how to get those equations of motion and what do they actually mean. So I'm focusing mainly on that, right? So we have the first one, which is Vf Actually, let me just use a different color. Let's check blue, see how it looks. So you have VF is equal to VI plus AX changing T. What is this? It's this one. Just take what you just took what A multiply, you just took changing T multiplied by A, and then you just took what VI to that other side, so you're left with VF that side. So you just manipulated this equation, right? You have your equation 1, that's your first equation of motion. Then the next equation of motion, you can write xf, which is position, final position, is equal to initial position, right? Plus initial velocity. Let me just write it like this: initial velocity multiplied by change in time, plus 1 over 2 a x changing t squared, right? That's your equation number 2. So here, what happened here, it's when you what? It's when you get your velocity, right? But you are using what? Is when you interchange velocity with displacement, because we already know that velocity is just changing x over changing time, right? If you check your initial one, you take your final one, is the same change in time, right? And then you substitute here, you get this, substitute here, you get this, and then you rearrange your equation, you get second equation, you get the second equation. You can try that and see what you get. So let's just look at the third one. You have FVF squared is equal to VI squared plus 2AX, right? Multiply by change in x. So this is 3. And then you can just have the fourth one, which is change in x is equal to 1 over 2 ax change in t. Some people write this as vf plus vi multiplied by change in t without the square. It depends on who is manipulating these equations to get your equations of motion, right? So these are your equations of motion. So you can see that we have a lot of xx. So this x is just displacements, right? So when you are looking at a flat surface, when you are in the air, when we look at free fall, that will change to y, right? And then ax will change to ay, right? Because they are in a different direction or in a different plane, but it's the same equations of motions. As long as acceleration is what constant, you will have your what you have your equations of motions, right? So we'll end here. So let me just give you a rundown on what we looked at, right? So we looked at equations of motions. We started with acceleration. What acceleration is the rate of change of change in velocity over change in time. And then we looked at what does it mean when you are speeding up, right? Velocity is increasing in the same direction and in which you are moving. And a negative acceleration is when velocity is decreasing in the same direction that you're moving. So it's just opposing your motion, yeah, slowing you down, right? And then we looked at zero acceleration where there's no change in velocity. So velocity is constant. When you have constant velocity, you have what? Zero acceleration. There's no change in acceleration. And then we looked at constant acceleration, right? It means that the velocity is changing at the same rate, right? So for each and every increment, let's say here, here, the velocity the acceleration stays the same. Changing velocity over changing time stays the same, right? So that's what we have, right? And then we looked at the equations of motion, which are called constant acceleration equations. They are only applicable in cases where you have what constant acceleration, right? We write our equation of acceleration. We have seen this multiple times now. You can manipulate that by exchanging Vx with what, with changing x, which is displacement, or maybe changing a lot of things there, right, to get your equations of motion, which is equation 1, 2, and 3, right? You can play around with that equation and look if you can be able to prove this, because it's much better to not only just memorize this, but to just memorize one equation, and then the other four you can derive them by know from that equation that you know. It helps you like free up space in your brain, so you don't have to memorize a lot of things, right? So we have reached the end of our video. On the next video, part 3, we'll be looking at how to solve questions by using what we have so far, right? What are the steps that you can take? What are some common phrases that are used in equations of motion? And then if we have enough time, we'll also look at, we'll try to solve an example to show you how you can put all of this together to solve a question, to answer a question in the exam, or in a test, or in an assignment, right? Yes. Thank you.